A radical equation is one where that independent variable x is located under a radical, and sometimes a radical equation will contain two radicals. And in that case, what we'll need to do is isolate one of the radicals, square both sides, or raise both sides to whatever power is needed to get rid of that radical. But that might get rid of one, but not both of the radicals. And if there's a radical that remains, we would need to isolate the remaining radical, square both sides again, and then solve for the x. So let's run that through with this example. We have two radicals here, so we're going to have to choose one of them to isolate. So let's choose to isolate this radical by adding square root of x plus 1 to both sides. So on the left, we have the square root of 2x plus 3. And on the right, we have 1 plus the square root of x plus 1. Now, we'll square both sides to eliminate the radical on the left, recalling that the square root of a quantity squared, these are inverse operations that cancel each other out. So we have 2x plus 3 that remains. Now on the right, let's recall the property that if we have two things added together on the inside of a parens that's being squared, that means that that quantity is multiplied by itself, and after we FOIL, we get x squared plus 2xy plus y squared. And this is a formula that really needs to be memorized. It's used a lot in algebra and calculus. So we look at the first term and we square that quantity. Our first term is 1 and 1 squared is 1. Then we look at the product of the two terms together and we double that, twice the product. So 1 times this radical is just the radical, and twice the product is going to be 2 times that radical. The second term is then squared, so that's our radical squared. So we have rad x plus 1 squared, so it's square the first, twice the product, square the second. Again, we see that this radical is being squared, so those operators are going to cancel each other out, and we'll take a cleanup step so that we can more clearly see where we are now. The x plus 1 no longer under a radical. Let's take a fresh look now to see that we still have an equation that contains a radical. So we essentially start all over, isolate the remaining radical, and then we'll need to square both sides again. So let's subtract this 1 from both sides, but actually we have two 1s that we need to subtract, so let's do both of them. And let's also subtract x from both sides. All of these terms cancel from the right, and on the left we have 2x minus x, which is 1x, and then 3 minus 1 is minus 2, so that's going to be a plus 1 that remains. And we still have 2 times that radical, x plus 1. Now we have a couple of options. We could either divide both sides by 2 to completely isolate the radical, but as you can see, that would generate fractions over here on the left. So instead of doing that, I'm going to employ another property, which is that if I multiply two things together that are being squared, that's the same thing as x times y, which is x squared times y squared. So the property says that if I have a product of two things that is being squared, essentially we can think about distributing that square over multiply. Which means that because we have multiply here, we can go ahead and square both sides now, and I will be able to distribute this square over multiply, which will get rid of this radical, and that's the whole point of squaring both sides right now. So the right-hand side, square the 2 and I get 4, square the radical and I get x plus 1. However, on the left, if there's plus or minus in here, we cannot distribute the square over. We actually have to use this formula. Square the first, which is x squared, twice the product is 1x, twice the product is 2x, and then square the second, which is plus 1. We can distribute a square over multiply. We cannot distribute a square over add and subtract. Let's now notice that we have landed at a true quadratic equation. And when we see that we have a quadratic, the process is going to be to set it equal to 0 and then look again to decide if we're going to try to factor it, complete the square, put it in the quadratic formula. We need to set it equal to 0 first before we can really decide what we're going to do. So let's distribute this 4 into the parens, recopy the left-hand side until we're ready to deal with that. 4 gets distributed in to be 4x plus 4, and then we'll set it equal to 0 by subtracting 4x and minus 4 from both sides. So all of this cancels on the right-hand side, and we have x squared minus 2x minus 3 is equal to 0, and we can see this does factor. This factors into x minus 3 times x plus 1. So we set each of these factors equal to 0, add 3 to both sides to get 3, subtract 1 from both sides to get -1. And now we need to check our answers. One of these could be extraneous, so we definitely need to check both. So I'll recopy the problem, leaving holes for the variables. We're going to plug our solutions into those holes. And first we'll check 3. 3 goes into both variable spots. 2 times 3 is 6, plus 3 is 9, so we have the square root of 9 minus. 3 plus 1 is 4. So this is 3 minus 2, which is equal to 1, so our first solution does work. But we have to check both, so now let's check -1. Let's plug -1 into both of those x spots. -2 plus 3 is +1, minus -1 minus 1 is 0, so this is also 1, and both of our solutions work.